Okay. We're gonna talk about inverses today. Okay? We're gonna start with a warm up. I am thinking of a number, and you gotta tell me what number I'm thinking of. Okay? Two? Not two. Mm-mm. I'm thinking of a number. No. No. What? Why? Let me finish. I'm thinking of a number. I'm gonna multiply it by 3. I'm gonna subtract 5 from it, and I get 16. What number? Everybody think about what number it is. Thank you, Sunny. I'm gonna write it down in 1 second. I have my number. I multiply it by 3, subtract 5, and I get 16. Yep. Write down what I said and how you got your answer, Sunny. I'll write it down 1 second. I multiplied it by 3, subtracted 5, and I got 16. Functions. So I multiplied by 3, subtracted 5, and I got 16. You said it already, Sunny. So I'm gonna write this out as like a function called f of x. I multiplied my number x by 3, and I subtracted 5. I would have gotten 16 equals 3x minus 5. Sunny, what was my number? Yep. Now, how did you get 7? Divide by 3? Yeah? Let's call that g of x. Can you guys find... We're going to go back to way back when we were doing this. This is called inverse relation and functions. Okay, little recall. Can you guys do this composition for me? And this composition for me? Of these two functions? You need to go up on the boards and do this?
No, no. I have to just get my seat.
What?
No, you don't. I do though. I literally wrote it down. I don't see it.
gonna go up with the boys.
We just plug it in.
Okay, 1, 2, 3. Yeah.
I can pick one of those boards of the big two. Like 3, 7. Wala bang markers or mga?
-5. I thought you said team. X plus 5 over 3.
It's okay. Go. Okay. It's fine. I guess. No, I'm right. Let's do it together. Oh, that's what I was thinking. So let's do it then. Just in case. Mr. Holloway and Pokemon Kingdom? Switch. Oh.
Yeah.
Why are we doing plus? Oh, never mind. Yeah, it's like really far away. It just be yeah. 3x minus 5 over 3. Wala na. Maybe? Do we?
Yes. We don't distribute that. It's just that's being addition. Added.
I'll show you that. I don't want to move. Kasi minus my plus. Hindi naman siya nag-cancel, so it's just here. And so then it's 3x plus I'll bring this side. Still, 0. Carlo? Maybe. So you're gonna simplify it. If it's just x simple. No, it's okay. I'll agree with you. Oh my god, it needs to be off the money.
You guys can keep simplifying. Oh, you did keep simplifying. I like it. It looks good. Isn't this property like not supposed to be commutative though? Like they're not supposed to be equaling the same thing when we did that?
I think it's just there's like
Yeah.
actually
At least gonna tell us we've done that.
without there it's both equals. So it's what? X plus 5 or x equals 0? I have like season 1 AOTH. And then you can
I thought you
dog like entire system. Okay, so why do they let you open? Like, why do they do that? Why do they force? So Mr. Holloway. Did Carla make that? The rainbow one?
what you did.
Both get them equal to x. Yeah. Some like no, just x. So this is like of f of x equals x. That's the same thing for that one, but just f of x. The threes just cross out. If one's multiplying, one's dividing. Then we get this, the fives cross out, we get just x. Same thing here, we get just x. Isn't this better with you? Functions of inverse. I'm gonna write that down. So let's practice this.
Lena, can you erase that board for me so they can see it? Thank you. Thank you. So we can use composition to verify inverse functions, which we're going to talk a little bit more about. Inverse functions. So if f of g of x equals x and g of f of x equals x, then these two functions are inverses of each other. So we had, f of x equals 3x minus 5. And g of x equals 3, nope, what was it, x plus 5 divided by 3. So before, I gave you the output of this function, right? I told you that my number equal to what at the end? 16. Equaled 16 at the end, and the start number was 7. Okay? And if I reverse my input and output, so over here, Sunny, what number did you start with when you were trying to get back to 7? 16. So you started with 16, and you got 7 back. If I said I ended with 19, what would my original number be? My original function. If I said that I multiplied by 3, subtracted 5, yeah, you did that so fast. Okay, now I want everyone to do it. What if I told you it was 38 at the end? So multiplied my number, subtracted 5, and I got 38. What would my original be? Everyone talk to your neighbor next to you. Raise your hand when you got it. What? Yeah. Okay, I'm gonna change. Remember when I said I multiplied by 3? Wait, Kennedy, look back up. When I said multiply by 3, I subtracted 5 from my original, and I got 16. Now, replace 16, and now we're doing 38. What's my original number now? You already made the function. That might help you. Raise your hand when you got it. Elijah, what did you get? 11. It should have been 11, yep. Did we not get 11? Yeah. So 38 equals 3x minus 5. Add 5 to both sides. Is it decimal? What else did we get? What are other answers? Okay, turn and talk to your partner. Did you all get 11? Elijah, what do we get? All right, 14.3 repeating. Now, before I just switch the input and output over here, can I do the same for the other numbers? Yeah? Does it work? Yeah? I want you to check this one. Check. Mark, I'm going to ask you the answer. If I check this, is it correct? Yeah, it works great. So when I'm talking about these functions, we can do this and just flip the tables because they are inverses. Is this the x? This is our domain of this function, right? Do we need to graph it? What if I graph it? Y equals 3x minus 5. What's the domain of this function? What's the domain of this function? Say it louder. Yes. What is our range of this function? Now let's do our inverse of this function. Plus 5. What happened? Mm-hmm. We're going to look back at this in a second. So, we're going to write this down. Ready? When a rule undoes another, so like our functions, we call it an inverse, which we already checked with composition. So these two functions or rules are inverses of each other, which means we have an inverse relation. Which means we can flip the domain and range of each function. So my domain of f of x, my first one was 7, 8, and 14.3. Then I went to my range. Leander, what was my numbers in my range? The f of x column. Start with 16. Yep, and 38. Now, when I did my inverse, that table flipped, right? It reversed. So my domain of g of x, yes, I can. The domain of g of x is our range of f of x. And our range of g of x was our domain of f of x. All we did was we reversed the tables, which we can do that because it's a inverse relation. Now there is a notation that we have to remember for inverses. So the inverse function of f of x was g of x in this situation. But we don't really write g of x anymore. We write it as, I'm going to write it first. I'm not even going to say it because I think you all know how to say this. Anyone have any clues of how to say this? Think back to geometry and inverses. Sunny, you have an idea? No? Amy, do you have an idea? A lot of people call it that way, and I used to call it that way too, but it's actually the inverse, f inverse of x. But some people still call it f to the negative 1, but we're going to call the f inverse of x. Put your pens down when you're done writing. Do you guys want to do another? I'm thinking of a number. 4. No, it's not the number I'm thinking of. It's close though. Are you ready? I'm thinking of a number. I'm gonna add 2 to it. Multiply by 5. Subtract 3. I get 37. I'll write it down in a second. Ready? I'm gonna add 2 to my number. Then I'm gonna multiply by 5, and I'm subtracting 3. I get 37. Okay? So first, I add 2. Shh. Why do you keep saying it? Multiply by 5. 3, I'm going to subtract 3. I get 37. Talk to your neighbors before we shout out. I like that you're going backwards. Write down the functions. F of x and g of x. Only do this after you write down the note. I'm just giving people that have written down notes something to do. Okay. I have my number x. I add 2 to it. Then I multiply all of this by what? 5. Then I subtract 3. Where should I be inside or outside the parentheses? Outside. Someone said it. So that should be my first function. Did anyone get the answer? Hands. Yeah? Lando, what did you get?
I got
6. Mark, what did you get?
Also
6. Elijah, did you get it? Okay. Okay. Yes. It should be 6. Mark, did you write a function to get? Yeah, what was your function?
I didn't get.
Okay, that's fine. We're gonna find g of x algebraically. Okay? We're gonna start way back up top. Is any more room? So we right now have f of x equals 5x plus 2 minus 3, right? Now, before I switch the domain and range, right? I can do that with inverses. So I'm trying to find the inverse of this one. I'm going to set this equal to y. Now, range is just an output. So y and x. If I switched it with the tables, I'm going to switch it right now. I'm going to switch x and switch y. So I have that. I want you to solve for y. So in my table before, I switched my x and y values in my table, in my domain and range. I'm doing that same thing, but just with the equation. See what you get for y.
So this is our original function, f of x, right? Now I changed f of x to y to do that. This is an output. Now all I did was switch y and switch x. So switch the places. I know you don't know why. Yeah. And then when math, I want you to get y all by itself.
Like that. Yeah, give me 1 second.
We're bringing in 6 here, right? No. Don't plug in that. I just want you to find, get y all by itself. Okay. We just got the function by doing the thing the other day. Now, forget about that. We got the function, that's what's fine. We have an input, we have an output. Just like we did to the table, we flipped them. So now we're just solving for y. Okay, I'll get y all by itself again.
It's the y. What'd you do for y? Like what's passing on that bottom step? I would, or if you don't want to do that, you don't start and be curved. And then it's distributed. Right. Did this one, the very bottom of the top. That's really both sides. So before you do this, you can do it like this, that's allowed, but notice, if you run yourself the y going, like by 5 minutes. Like, and they both work, like realization, but I think that second approach is going to be the little easier way. Why? But you better divide one side by 5. The whole thing is going to be 5. Naomi, can you see what? I'll take it over here. How's it going, guys? So all you have to do is we're swapping the x's and y's, right? Because we see that that happens with the invertees. Once we have that very bottom expression that's up in the fourth, can you solve that for y? Like that very bottom, can you rearrange it and just get a y equals out of it? I don't know. So here it is, right? Here it is. So you distribute it. 5y plus 10 equals x. These are equals x. You had an x equals that, and then it disappeared. So you swap, right? So here was the original, and then we just switched any x, we replaced with y, and any y replaced with x. So these two literally just, they change letters. And the reason this happening, just like we saw in the table. Well, I think that we should rework this because it's x equals still. Because it still has to be the same thing to both sides. So just write x equals 3 here. I like your set. Now let's start. So we're in the 37. So I like that idea. That works when you plug in a different number. If I said right here to solve everything, if we erase these lines, if I said solve this for y, could you?
Guys, if you're done, there's a way to verify it, right? Make sure you did it
I
right.
think you can for sure.
I have to check.
Mark, did that make sense as I was talking there too?
I wasn't really paying attention to
Okay,
what you
no
were
worries.
saying.
I'm just trying to find your stuff. You're solving this for what happened here, x? I think you just keep it x. I think it'll be okay. The only thing that I don't see is the light how you had. Oh, you're checking on that, right? Okay, never mind. Yeah. Just that. It's just ugly fraction. Then you're gonna add 2 here. So you're gonna subtract 2, which is like 10 over 5, right? So then you can make a common denominator. You're almost there. So go ahead and write this. It's gonna be ugly for a second, but then you're gonna do the x plus 3. You have x plus 3 over 5 equals y plus 2. So I want you to write that nicely. So yeah, x plus 3 over 5 just needs to be there. Okay, so now you want to subtract 2 from each side. Okay, so it's already seen it on the right side. You need to do it. That, bruh. And then.
Okay, if you're checking, go ahead. I'm gonna do it up here.
Could you make the 200? I'll take it. You're gonna set up on the first bit. It's the easiest bit, which is good. I have.
This should have been your final answer. Thumbs up if you got it, thumbs down if you didn't, thumbs in the middle if you were getting there. Okay, for my thumbs down people, do we have any questions about the math getting there after seeing it? Yeah. Because I want to get y all by itself, so I don't really want to add more onto y. So I would just divide it by both sides, move it over. So 5y plus 10, okay, x plus 3. So x plus 3 equals 5y plus 10. So what would you do next? So x minus 7 equals 5y. So x minus 7 equals, is that the same function? No, it's not. I don't think you would get the same answer if you did it that way. We can check it though. So we got x3 over 5 This is what we got when we didn't distribute. Michael, what did you get when we did distribute? Yeah. So we got 7? Okay. Minus 7. Oh. Got the same function. So you could have done that too. Because if we did 2 the denominator of 5 and then combined denominators, that would have been fine. Okay. Oh. Back to smooth draw. Did we check it? Did you check this one? Anyone? No. Okay. If you did, yes. This is also a way to find an inverse besides just looking at the domain and range or checking it. So all you have to do, I would put this in your notes 100%. 2. No. To find the inverse of a function, switch. What did we switch? What 2 variables? That's my phone. Brent. Never mind. Angel answered for you. Yep, switch x and y. And then solve for y. And that's the end of class. Get his thumbs up. Oh, you guys want homework? I almost forgot. No. Homework 5.6. Page 275. 17 through 27 odd. I do a light homework. Only 5 questions. It's 5. You know what? I'll also add 31. I haven't looked at it in a second. And 31. Mm-hmm. Oh, happy birthday. Trevor's birthday was over break. Who went to Anchorage? Whose was it? Whose birthday? Who has braces? Amanda, who has braces in here? Mm. Amy, was it your birthday? Happy birthday. Yes, don't forget all your phones.
Peace out. You can sit back up on there. What's your number? I'll take that.